Hello, this is day 5 of this whiteboard talk, and oops, I don't know why it does this. Let me turn this off, do this again. I'm still working on queues, and I'm still working on DB queues. I'm still working on dynamic dispatch, and I found out today, that Haskell has it. It has something, there's a special extension called existential, can't spell it, but it doesn't matter, existential quantification. And what this allows you to do, as far as I understand it, is you create an item, create a data object called foo, and then you can do something special like say for all A, where A implements a particular class, let's call it bar. Then you can do like anything you want here, but you do put like a foo A. That's like the basic generic example. So then, excitingly, you can make a list of a foo, and because the A isn't up here, it can be any foo containing any type of A. And so let's say we have XS and it's that, then we can make it equal a bar, or sorry, a foo of a bar, whatever bar has, comma, foo of a B, and whatever B has its arguments, and so on and so on. And then you have a list, and in fact this does implement dynamic dispatch. I've tried it. So if bar has one implementation for a particular function in the foo class, so if we had foo A, class foo A, and it had a function called foo, lowercase, and it took an A and returned an int, bar could have its own implementation and B could have its own implementation, and we're fine. So what this means to me is that I can go ahead and go back to the earlier method that I was using, where I had classes, had a class that represented the QImpl, and then I had things that implemented that class, and I think that is the best way to do it. The way I was doing it before, which I didn't really explain fully because it's just so complicated, is that I had the function, and it had the closures of the function, and then it had created like this QImpl data type, which had the had its functions, func1, func2, whatever. Okay, maybe I'll call that add and remove because that's what they are. Add and remove, and they would take, and they would. And so this just had equals and created anonymous functions for those. So the problem, of course, is that then you have this little wrapped up closure, which you can't name, you can't access. There's no way to be able to say, oh, for this particular closure, I want to know what the size of the list is. Oh, you can't do that because it's a closure. There's no way to name it. There's no way to determine one closure from a different one. So it's impossible to do that. Or it's very hard. Actually, I found a way to do it, but it's such a hack, I can't believe it. What I did is I added another field. There was a t-bar of a function that returned its internal data. So if this had a list of values, it would send that to a function. So it would have a t-bar of a function that would accept that and then return back an action to do. And it would do an STM of an IO because QImpl is part of Q, which is has an STM, or has a t-bar of QImpl, so we want to make the whole thing about accessing QImpl and this function atomic, so that's why it's STM, because with the STMs you can link them together and make the whole thing atomic. So that was the idea, and then it would return an IO action afterwards, so that the STM could direct an IO action to happen after it determined something about the queue. So we have the list of vars, and then what would happen is that Q import would have another special function called update, which just would have an STM.io, and then our particular dbq import would implement update in a way where it would actually call this special tvar, which is something that would be returned outside of the whole system, the whole loop of QImpl. It's not. This is not related to QImpl at all, but there's a variable reference to that. So it would update that, from some configuration or whatever, and so it would actually, call that with some configuration or whatever with its internal closure data, and that would go ahead and do whatever update it needed to do. Blah. So that really sucks because first of all, dbq it has to be inside a specific class. It cannot be a generic thing that you add to Q or some sort of generic class that dbq can inherit. So it has to be code that you put in every single implementation that you want to do this. So it's awful. It stinks, and it pisses me off that people recommend it this way as the as alternative to OOP type hierarchy. It's just because it's ridiculous. It works in the simple case, and it's very hard to understand. Once you understand it and once you see it doesn't work, it's kind of like you're wasting a lot of time. So I'm really pissed off that people do that. It's like they're armchair programmers. So yes, they fucking suck. So moving on. I can use this other way, like this, to do the same thing. Because now cat T work group can now hold on to a dynamic list of different things that all implement QImpl. So, and we can just use a wrapper class like QImpl wrapper, and then there you go. And then when it calls the methods, it'll calls functions. It will call them properly. It'll call the different ones according to what type they are, and everything works fine. And then also what I can do is I can actually get into it and take a look at what the value is. There's two ways to do it. I mean, for my purposes, all I need to do is for the disk-based queue, just keep a separate reference to it, and then I can go and muck around with it as much as I like. I can find out what the size is. I can add items, remove them. I can set up a flag for error. I can tell whether the disk record is empty or not, or what status it is. So yeah, this will work perfectly. It's much simpler and much easier, and it's lovely. So besides that, geez, I think there's something else that I wanted to talk about, but I forgot. Let's see, there's fresh tasks. Oh yes, there's one other issue which I came up with a solution, but I don't remember it right now, but maybe it'll come to me. We have fresh tasks, which is a list of keys. This is part of the whiteboard system. So the keys represent the objects. What happens is that an action function will take a key, go to action function, and that will return it. And that will, that will actually return a monad, which is called a cat T monad, because I have the special things where it's like a monad, but you can change categories. You can do like a CPU category and do some things in the disk category and so forth. But the main thing that it does is it adds or it writes. Sorry, not writes. It reads from other keys. So it might add in a key object or read a key, return in an object. And the system, the whiteboard system, is going to keep track of all these and turn it into a giant graph. And like I said, it's going to have to be a DAG graph, which is, I forgot. Anyway, it's just one way. You can't like have cycles in it. Directed asymmetrical graph. So it has to be a directed asymmetrical graph, and there's no way to tell that. So I had like this algorithm for determining it, which is going to be basically a debug mode, and then production, it won't have anything. And if you do happen to have a cycle in production, well, damn to you, because the thing is going to go into infinite loop. But that's why there's debug mode, and I think it's fine. So that's that. So how I'm going to do this is, right now cat T doesn't have anything like this, but our cat T workgroup doesn't have anything like this, but I'm going to put in a system where it can take two things: a queue of any type of value and a function that converts that value into a monad, a special cat, or a cat T monad, cat TIO monad, basically. And so what will happen is that this will be called like the input queue, and just like everything else, and also probably have like a default cat. And so there's, okay, to review, cat T workgroup has a thing where it takes categories to count number of threads, thread count, and then what will happen is that for each category it will spin up like so many threads that will process the category. So it's pretty simple. It'll basically have these threads listed on this queue of B, and once they get a value to work on, they'll go turn into a cat IO using this function here and run it, and that will do the same type of thing where you can switch categories and blah blah blah, and that will automatically, in the cat T workgroup, update the main mapping where it maps categories to queues of jobs, and then each job becomes so each job happens to be a continuation of just a work, which is, again, like up here, what that would be is like the CPU cat does some stuff, so this would be a continuation. Actually, the whole thing would be a continuation, but just when it reaches a disk cat, then it stops and creates another disk continuation. And that's how it works. And that's cat T workgroup. And I should work on that tomorrow, and that's about all I wanted to say. And I gotta go anyway. So happy Thursday, everybody. All right, bye. Oops.